we are continuing to talk about quadratics. Surprise. So we're going to continue to kind of learn and expand upon what we learned about last class, which is dealing with the vertex form of your quadratic equation. Again, so last class we talked about completing the square, how to use completing the square to find your vertex form. And the reality is that a lot of times when we're talking about parabolas and quadratic equations, we use it for what we call projectile motion, which is like when you throw a ball, or more realistically, when you're dealing with the trajectory of a missile, unfortunately. And when we're trying to find the vertex, our numbers just aren't always going to be perfect and nice and 2, right? So we like to kind of create formulas to be able to deal with not nice numbers. And so this generalization that you're about to learn, we're going to derive, we're going to create this generalization together, which is fun. And is that it's nice and helpful for when an equation doesn't look as nice as we want it to be, or maybe when we aren't sure how to turn it into vertex form, we can at least find the vertex without turning it into vertex form. So the goal when we try and come up with formulas is that we want to be able to do all of the mathematics that we normally do when we're trying to find this and process this, but notice that we have no numbers. So we are going to find the vertex form of this general equation. There are no numbers. So we're going to do this all without numbers. This is called abstract algebra. I took a whole class about it in university. It's a whole section of mathematics where you just deal with mathematics and doing the same thing that you always do with the numbers, just now there just aren't numbers there. And so you just kind of have to keep track of those variables and what happens to them. So let's talk about it. When we first start completing the square, we need to first say, is A equal to 1? And it's not. A is equal to A right now. It's not 1. So what we have to do when we say, oh, A is not equal to 1, is that we factor out A. So we have A out front and then parentheses. Now, taking out your greatest common factor, what is left with this AX squared is just X squared. And then I'm going to factor out this guy. Remember that when we're taking out the greatest common factor, what we're really doing is that we're dividing the terms, right? AX squared divided by A gives you X squared. So BX divided by A then becomes B over A times X. And then remember that we add something here to complete the square. And then with this plus C over here, we subtract that same thing out. But we didn't subtract out just that thing. We subtracted out A times that thing. So we're going to subtract out A times that thing. Okay. So I've set up a space for me to be able to complete the square. What I needed to do first in order to set that space for me to complete the square is that I first factored out A and brought it outside. Now, my next step, and that's a B, not a 6. My next step is then to take this term right here, this number right here, divide it by 2, and then square it. B, we can have this as a thought process. B divided by A divided by 2 is the same thing as B over A times 1/2. Which means that dividing B over A by 2 really is just B over 2A. And that whole thing needs to get squared. So over here, what it ends up being is B squared over, and remember both the 2 and the A need to be squared. So that becomes 4A. Let me zoom in so you can see what I've got going on here. Okay. So, okay. We're starting to complete the square. It's happening. So we've now got to try and simplify this down, because next what we would do is turn this into our perfect square trinomial and it's already in a perfect square trinomial, so we're going to factor it down. So it's going to be A. And remember that it's always X and then plus because this guy is a plus, and then it's this guy divided by 2 is the thing that we put here, right? If it was 4, then it would be 2 here, right? We always divide this guy by 2 to put our number here. So what's going to go here is your b over 2a. Close parentheses, squared. So I've taken that perfect square trinomial, brought it down to a factored thing. And then I'm honestly only going to do a little bit of things here to simplify. Realize that no, that's a squared, not a. That this a right here as a over 1, it would be in the numerator if we multiplied these fractions together. So this a cancels out with one of our a's in the denominator. And so we're left with plus c minus, and then it's b over 4, and then just a, not squared anymore because it got canceled out with this a on top. So we've put it into our vertex formula, and this formula works every single time. You could memorize this formula if you wanted to. I definitely don't recommend it. Do not recommend it. You could just memorize this formula, and then no matter what values you get for A, B, and C, they could be crazy numbers. You can plug them into here, and you can get the vertex formula every single time. What we want from the vertex formula is the vertex. So in order to find our vertex, remember that you have ax minus h squared plus k. So your horizontal value of your vertex is right here. It's written in the formula as negative h. So then since it's positive here, that means that your h was negative, which means that your x value for your vertex would be negative b over 2a. This was confusing and this was tough, and I bet you've never seen abstract algebra like this before. You're more than welcome to review or go back, rewind, and listen to it again and think about it again as many times as you need. But since this is the horizontal aspect of our vertex, our x value right here is not going to be the positive version, but since it's inside the house, it's a bad kid, right? So it's grounded. So it's going to do the opposite of what you think it's going to do. So it's going to become negative b over 2a. And then technically our k is all of this. It's kind of a mouthful. C minus b over 4a. A lot of times because it is kind of a mouthful, and people think, well, if I know x, the x value of the vertex, an easy way to find then the y value of the vertex is then to say, okay, negative b over 2a, well then the y value would be what I get when I plug that in to my equation. I could just get my x value and then plug that back into my equation. Whatever I get for y is the y value of my vertex. So that's a lot of times how you'll see the equation of a vertex written. We're going to practice using this and our shortcut that we learned last time about how to find then the next points about this idea of the relationship of this vertical transformation, like we talked about last time, to be able to quickly graph things. And that's going to be important just to like solidify your understanding and to be able to engage with quadratics in a quicker way. And hopefully your understanding kind of comes full circle. Okay. So we are going to sketch a graph of each of the following functions, label the vertex, axis of symmetry, and at least 5 key points, including all x-intercepts. Including all intercepts, not even x. Okay, so first of all, we're going to practice finding our vertex using what we know about this. But remember that our formula relies on this idea of ax squared plus bx plus c. Your a has to be the number that's in front of x squared. So sometimes what I like to do is I like to reorganize things if x squared isn't first to move it around so x squared is first. Remember, that negative value needs to stay with x squared. So this becomes, I say that and then I don't write it. So silly. Okay, negative x squared, and then this is a positive 6x. So that's rewriting it so it's in the general form, the standard form. And so now it might be a little bit easier to see that a is -1, b is 6, and c is 0. So your vertex is negative b over 2a, so -6 over 2 times -1, and then f of that value. We could even do the C minus B over 4A and then double check, which would be kind of cool. So we could do 0 minus 6 over 4 times negative 1. Okay, so negative 6 divided by negative 2 is going to be positive 3, and then 0 minus, and then that's 6 over negative 4. So it's going to be plus 6 over 4, so it becomes 6/4. Whoa, that's not right. 0. So sorry. This needs to be b squared. So silly. B squared, it's late at night. I apologize about that. This needs to be b squared. I totally forgot to square b squared here, or to square b to make it b squared. That is why things were off. Okay, so then this needs to be 36, which definitely is the correct answer. So then that needs to be 36 over negative 4, which is negative 9, which turns that into a plus, which means that it's a positive 9. And if you plug 3 into this equation, you'll notice that you also get 9.